Hello.
Hello.
Hi, Diksha Didi.
Hi, good afternoon.
Good afternoon. So, yesterday the meeting disconnected, and today we'll continue with the loop through a multidimensional array.
Okay.
Alright. To loop through a multidimensional array, you need one loop for each of the array's dimensions. So, if you have two dimensions, you will have to have two loops, like one loop inside another loop. If you have three dimensions, you'll have one loop inside another loop inside another loop. Right? So, we are going to see both the examples of a two-dimensional and a three-dimensional arrays loop. Right? So, the following example outputs all elements in the letters array. So, over here, let's just copy this example and paste it over here, and we'll just uncomment this part, include IOStream, because we need to use IOStream. So over here we have a letters array that will contain string letters. We could have also said char over here, right? And we could have given single quotes everywhere, but instead of changing, let's just keep it string only. So we are saying that this letters array will have two arrays, and each of those two arrays will have four elements, right? So this is the two-dimensional array that we created before also. Now we are looping on the main array. So we are looping on this array, right, two times because it has two other arrays, right? So we are looping on it two times, right? And then inside that we are saying for int j equals to 0, j less than 4, j plus plus, right? So we have two loops for two dimensions. So what is happening when I is 0, the full j loop will run. Then when I is 1, full j loop will run, and then the loop will end. So when I is 0, j is 0, so it will access letters 0 0, so it will show a. Then it will access letters 0 1 because I will remain 0 and j's value will keep on incrementing. So then it will access b, then it will access c, then it will access d, then it will go back to I, it will increment the value of I. So now it will access the elements of this second array inside our letters array, and then it will loop on each of its elements. It will access I 1 0, so the first array's 0th element, then 1 1, the first array's first element, then 1 2, then 1 3, right? So this is how it will show us A B C D E F G H. So we are getting an error over here, unexpected unqualified ID. Alright, I don't know what the error is actually. So let's just try to run this because we just copy and pasted the code. Oh, I forgot to give this an int main. I'm so sorry. I forgot to give this in the main function. Int main. Alright, now this will work. Right. So now it's showing A B C D E F G H. Is this clear?
Yeah.
Alright. So similarly, we can loop on a three-dimensional array. For three dimensions, we have three loops, right? So over here we have the main array. Then inside that we have two arrays, and inside each array we have two arrays, right? And then inside each of these two arrays, each of these arrays we have two strings. Alright, so we are saying int I equals to 0, then we are inside that we are saying for int j equals to 0, then we are saying int k equals to 0. So what will happen? I will remain 0, j will remain 0, and k's value will change. So I0 means this, right? J0 means this, and then k's value will change. So it will access 0 0 1, 0 0 0, that is A, then it will access 0 0 1, that is B, right? Then it will increment the value of j, so it will access 0 1 because j is over here, so 0 1 0, that is C. Then it will access 0 1 1, that is D. Then because these two loops have ended, it will go back to I, it will increment the value of I, so it will now come to the next sub array, right? Inside that we have j0 for it also, so it will go on this array, right? And sync k0, k less than 2. So then it will access 1 1 0 0, that is E. Then it will access 1 0 1, that is F, right? then it will increment the value of j. So it will come here on this second array. So it will access 110, that is g, and 111, that is h. So pretty complicated it's getting when we have three dimensions, but when coding itself, we just need to know the concept that each for loop represents one dimension. So
Okay.
is this clear, the thing, or
Yeah.
all right? So now that,
Can you show the
yeah,
code once again?
yeah. So this is the code over here. We have the main method, we have the strings array, that's the three-dimensional array, and for each dimension we have one loop.
Yeah, it's clear. Okay.
So now that we have done the explanation, now we'll go on to create our battleship game. So for that, I suggest you should also create a REPL and code side by side so that your concepts remain clear.
Okay.
All right. So I'll also create a new REPL battleship. So we'll just go on home. We'll just create a new REPL. C++ battleship. Alright, so the REPL is being created. So let's just see what we have over here. Why multi-dimensional arrays? Multi-dimensional arrays are great at representing grids, right? So you can represent a grid, right? Like in Battleship, you have rows and columns. Similarly, through multi-dimensional arrays, you can represent grids. This example shows a practical use for them. In the following example, we'll use a multi-dimensional array to represent a small game of Battleship. So it's not a very complex game of Battleship, but it's a small game of Battleship. Enough to have fun, right? So
Okay.
so we have a boolean array, right? So we have a boolean multi-dimensional array with two dimensions, that is ships, right? And I think one is there to indicate there is a ship. So we have all these blank spaces that are represented by 0, and one is where we have the ships, right? So this is our ships array where or the water is represented by 0 and the ship is represented by 1, right? So this is a multi-dimensional array. We could have also done the same thing with a single dimension, but uh, multi-dimensional array makes it much easier. So this is an example of multi-dimensional arrays also. So we have the ships array, right? The multi-dimensional array. So now let's move on to the next part. We have hits 0. So we will track the number of turns the user has taken and the hits that he has done, right? So how many ships he has hit and the number of turns the user has taken. So in the start, the hits is 0 and the number of turns is 0, right? So we'll keep track of both of these things, hits and number of turns. Till now, is it clear?
Yeah, it's clear.
Yeah. Now, as you can see in this, we have four ships. One ship over here, one ship over here, one ship over here, and one ship over here. So we have four ships. So now what we have to do, we'll give a while loop while the hits is less than 4. While all the ships have not been hit. That's what we are saying in this while loop. While all the ships have not been hit, we'll define an int row and column variable, right? So we'll define an column and row variable in this statement, and both variables data type will be integer only, right? So we saw the shorthand in the variables chapter. We could have also defined like int row, int column, right? That would have also done the same thing, but we are just defining them in a single statement. So now, what we'll ask for the user for the row and the column, right? So we'll say first cout selecting coordinates, right? So we'll tell the user selecting coordinates. All right, and we'll also give a new line because it by default does not give the new line. We'll just say end L, and we were not doing using namespace standard, so let's just do it over here using namespace standard. So are you just writing this in your REPL also?
Yeah, I'm doing side by side.
Alright. So we'll tell the user that we are selecting the coordinates, right? Then we'll say choose a row number between 0 and 3. So we'll say choose a row number between 0 and 3. So we'll say cout choose a row number between 0 and 3, right? So now we are telling the user that choose a row number between 0 and 3, and we'll take in the input from there only. Where this cout has ended, we'll start taking the input, and whatever the input is, we'll save that in the row variable that we created over here in the while loop. Next, after this, we'll cout choose a column number. So we'll say choose a column number between 0 and 3. Now the user will choose the column, and whatever the user enters, we'll put that in the column variable. Alright, so next what we'll have a if condition. We'll check if ships and whatever row the user entered and the column. So I'll just explain this. So we are saying ships, in ships, like for example we enter the row 0, so ship 0, so the 0th array, and we enter the column 0, right? So 0, so that is 0, and note this is boolean, so this will give us false over here. If we enter the row 0 and column 0, we will get 0 from the ships array, right? 0 represents false, right? So it won't go in this if statement. But if we give, for example, row 0 column 1, so row 0 column 1, right? So over here we'll get 1. 1 represents true, so it will go in the if statement. So let's interpret the user has given the row 0 and column 1. Then what we have to do, we'll say wherever, that means the user has found the ship, that means the user has found the hit, right? So we'll say column, now that the ship is hit, right, we can say 0. Now that the ship is hit, we can remove the ship from that position, right? We can increase the hits, right? That the number of hits we can increase because the user has hit one ship now, right? And we can tell the user about it, that hit, right? And we can say 4 minus the number of hits left. So what this code is doing, it's telling the user it's a hit. Then whatever the number of hits we have, we are subtracting that from 4, because the total number of hits that are there can only be 4. So if we have one hit that we have already done, so we'll say 3 hits are left, right? So we'll tell the user how many hits the user has to do now, right? So how many hits are left for him. If we get 0, meaning we don't hit a ship, we encounter water, so we'll say else, we'll say it's a miss, right? So we'll say miss, and what we'll say, we'll just give new line, and we just remove all of this, right? And after all of this is done, if whether it is a hit, it is a miss, that does not matter. The number of turns the user has taken will increment by 1, right? So in the end, when hits is equals to 4, when the user has hit all the ships, it will come out of the while loop, right? And out of the while loop, we can show victory, right? So when the user has hit all the ships, you can show victory, right? That now the user has hit all the ships, now he has a victory, right? And we can say see out. We can tell the user in how many turns the user won. So you won in, and then we can tell number of turns, and then we can say tones. So what this is doing, this is saying that you won in, for example, we have taken 5 turns, so you won in 5 turns, right? So if number of turns is 5, we'll say you won in 5 turns, right? So this is a very simple battleship, and as a developer, this may not be fun as we know all the coordinates of the ship, but as a player, this a small game may be fun, right? So this was a very simple code in which we saw all the things that we have learned, mostly the things we have learned, like the array concept of arrays, data types, variables, then the IO stream library. Then we have also used the if statement, we have used the loop, right? So we have used almost all the concepts that we learned in this battleship game, right? So this is a pretty fun game. So is this game code clear?
Yeah, I'm just writing it. Just a second.
Yeah, it's alright. So if you have any doubt, please feel free to ask.
Okay, thank you. Okay, then. Thank you.
Alright. So now let's just try running this game. So select the coordinates. First we'll select the row. So for example, we'll say 2, and let's just say the column 1. So it's a mess, right? Let's just say 0, and you can say column 1. So hit, right? Alright, so 3 left, and after that we get selecting coordinates directly after 3 left. So this is not good for the user. So after hit also we should add 2 new line characters, so that it's easy for the user to basically read what we are saying. So selecting coordinates, we had 2 1, right? Then selecting coordinates like 0 1, so it's a hit. Now we have 3 left, right? Let's just say 1 1, so it's a miss. Let's say 0 and 2, so it's a hit. And let's just say 3 3, miss. 3 2, so it's a hit, and we have one ship left, so that's on 2 and 3, second row and third column. So that's a miss. 0 1. Oh, it's on 2 2, sorry. So it's on 2 and 2. So hit, 0 left, victory, you won in 8 turns, right? So we took 8 turns to sink all the ships. So very simple game, very basic battleship game. So you can just play your game also and just test it out.
Okay. It's the same code, it's working.
Yeah.
Fine.
Alright. So this was the first game that we created, and later we'll have so many concepts like functions and classes. So we can create advanced games also later. Very simple game. So now let me just go back to the tutorial REPL. Alright. So now we can move on to the next concept, that is structures. Right. So C++ structures. Structures, also called structs, are a way to group several related variables into one place. Like we have your arrays that group several values in one place. In structures, you can club or group together several variables of different data types too, right? So these are more powerful than arrays, right? So each variable in the structure is known as a member of the structure. So this is a term, member, right? So each variable in the structure is a member of the structure. Unlike an array, a structure can contain many different data types. So that's a plus point of structures, that it can contain many different data types. Like you have in Python lists, you can have many different data types, but you cannot have variables in it. You have values in a list or an array, but in a structure you can store variables, right, of different data types. So now we are going to see how to create a structure. So to create a structure, use the struct keyword. So we use the struct keyword. So we'll just go in here and we'll say struct, and this is a built-in keyword, right? And declare each of its members inside curly braces. Then we'll declare each of its members inside the curly braces. Like we can say integer mynum string my string, right? So we can have as many variables as we want of any data type in our structure, right? After the declaration, we'll specify the name of the structure, right? So we'll also have to give a name to the structure. Now we have created the structure, we also have to name it, like my structure, right? And after that, we'll end it with a semicolon. So this is a very basic structure, right? Now we'll actually see how to use it, right, and how to access the structure members. So to access the members of a structure, we can use the dot syntax. So this is the dot syntax. We can say whatever structure we have, like my structure. So we have my structure, it's my num we have to access. So this will say take my structure and access its my num variable, right, and that is equals to 1, right? So it's very similar to dictionaries in Python, where you have key value pairs. Similarly, you have variables in structures, right? But it's very similar. So we have my structure dot mynum is equals to 1, for example. You can say my structure dot my string is equals to hi. All right. Then we can also show the values of our structure variables. Like we can say my structure dot my num, right? So if we show the value of my structure my num, then we'll get 1. If we show the value of my structure my string, the my string variable in my structure, then we'll get, all right, hi. All right.
Okay.
So we can have one structure in multiple variables too. So like we create a structure and we have it over here in string in a single variable my structure. We can have multiple instances of this structure also, like my structure 2, my structure 3. So we can have as many instances as we want of this structure, right? That won't be a problem. But we'll have to separate each name of the structure by a comma. All right.
Yeah.
All right. So we have a like a practical structure over here. Right now, this was just a dummy structure. we also have a practical structure like a car structure, which will have brand, model, and year, right? And we are creating two instances of it, my car 1 and my car 2. So let's just delete this. Should I delete this code? Is it clear?
Yeah, sure. Yeah, yeah.
So over here we have a structure, right? That is basically a structure to represent a car. So it has brand, model, and year variables in it, and we are creating two instances of it: my car 1 and my car 2. All right. Next, we can give the values to all of these. Uh, so we can say my car 1 dot brand is equals to like Volvo or BMW. My car 1 dot model is equals to x5, and my car 1 dot year, as that is an integer, we'll give it an integer 1999. Similarly, we can give values to the my car 2 structure also. So my car 2 dot brand, like let's just change the variable names first, and let's just see what we are given: Ford Mustang and 1969. So Ford Mustang and 1969. So we have given values to both the structures, and when we try to print, like for example, my car 1 dot brand, we'll get BMW. When we try to show my car 2 dot brand, we'll get Ford. When we try to show so these are two structures with two different with the same basically variables but with different values. So my car 1 also has the same variables, and my car 2 also has the same variables with this but with different values. Is this clear?
Yeah, it's clear.
All right. So next we have named structures. So we have two types of structures. One is the unnamed structures, that we have this, and we also have named structures. So named structures are like data types in C++. So like you create a string. So to create a string variable, you say string and like x, right? So string, we give string before x, right, to tell that it's a string variable. Similarly, if we have a name structure my car, we can say my car x is equals to something, right? So that's a name structure. So we'll just delete this code over here, and by giving a name to a structure, you can treat it as a data type, like we treat string as a data type, num, integer, bool, right? These all are data types. Similarly, we can treat a structure as a data type too. This means you can create variables with this structure anywhere in the program at any time. So to create a name structure, put the name of the structure right after the struct keyword. So instead of giving it like this after defining the structure, we'll give the name just after the struct keyword. So we'll say struct, we'll say my data type, right? Then normally we'll just give it the variables like int minor, string my string, right? So the difference only in name structures and unnamed structure is that we give the variables after the braces. In unnamed structures, in name structures we give the name of the structure after the struct keyword, right? So this will create a data type for us. In the unnamed structures, we had to give to create instances, we had to give the variable names just after the braces. But in name structures, we have to give we have to to create the data type. So to create a data type, we'll have to give the name of the structure. In that case, in unnamed structure case, we were giving name of the instances. over here in name structures case, we are giving the name of our structure itself to create instances at any point in the program, right? So see it, an example will make it more clear. So we can say like my data type, so I can create an instance of my data type structure wherever I give my data type like this and X, right? So this is an instance of my data type. We can say my data type Y, we can say my data type Z, and we can have infinite instances of our my data type structure, right? Over here in unnamed structures, we were bound to give the instance name right after creating the structure. But when we have a name structure, we can create the instances at any point in the program, right? So a practical example will be the car structure only. So instead of an unnamed structure, we are creating the structure car, but it's a named structure. And sorry about that, I'll give it in name. So is this clear, the example of the name structure?
Yeah, it's clear.
All right. So it's like your own custom data type with its own properties and methods. You can also give methods. So you can also give functions also inside your structures, right? So uh,
Okay.
that we'll see afterwards when we learn about functions. So like over here we are creating the my car. We are creating an instance of the car. You can say it's a data type. So you will just now call it data type. So we are creating an instance my car one of the car data type over here and giving it the values, right? So it will work exactly the same as it was in the unnamed structures case also, right? But it's much easier
Okay.
to understand with name structures. All right. So next we are on the concept of references. References and pointers are an advanced concept, right? And these are very important to learn as you will handle the memory with these concepts, right? So you can change and handle the memory with these references and pointers, right? So I think we'll be able to complete references today in the meeting, and tomorrow we can do pointers. But let's see. So references. A reference variable is a reference to an existing variable and it is created with the AND operator. So let's just start with a normal example without looking at references. What if you have a string variable x and you say its value is 4, right? And then you say string y is equals to x. So what do you expect it to happen? If I see out x and L, and we'll say C out, sorry about that, C out Y and L. So tell me, what do you expect to happen? What should be the output on the screen according to you?
Food and X.
Ford and X. No, this is not in quotes. This is not in quotes over here.
I should double 4.
Yeah. So we'll get double 4. But what if we change value of X to like,
How come it came in two different lines? Acha, and L, sorry.
yeah. So you said Toyota. So I changed the value of X to Toyota. Right now, what do you expect it to bring?
It won't overwrite right now.
What?
If it were in a loop, then it would have overwritten the X.
Yeah. So what should be the output? It should be Toyota and Ford, right?
Yeah.
All right. And now comes references. What if I give an and before y? This over here will create a reference to x, meaning x and y are two variables that are pointing to the same memory location. So over here, for example, how should I tell you about it? So over here, for example, you have one place, right? You have one place, but there are two roads to it, right? You can use two roads to. There are two paths to one place, one single destination. There are two paths to a destination. So you can use any path, but you will reach to the same destination, right? Similarly, x
Hmm.
and y are two variables that are pointing to the same memory location. So if I change the value of x from Ford to Toyota, then the value of y will also change because they are both accessing values from the same memory location. So first, x is Ford and we are saying and y equals to x, meaning both are Ford. But if I say x is equals to Toyota, then that Ford in the memory location will change to Toyota, and x and y both are pointing to the same memory location, so both value will change to Toyota. So if I change x to Toyota, then x and y both will show us Toyota, and if I change y
Okay.
to Toyota, then also both will show us Toyota. So this is references. When you want two or more variables to point to the same memory location, then you will use references. So over here there's an example of food, pizza, and meal equals to food. So we can use either variable name food or the reference name meal to refer the food variable, right? So it will be the same thing. Next, we are on memory address. The and operator is not only used to create references; it is also used to show us the memory address of some variable. So, for example, in the example from the previous page, the and operator was used to create a reference variable, but it can also be used to get the memory address of a variable, which, which is the location of where the variable is stored on the computer. So when a variable is created in C++, a memory address is assigned to the variable. And when we assign a value to the variable, it is stored in this memory address. So as you know, every value is stored in the memory address and every variable is assigned a memory address, right? So to access it, we'll use the AND operator. What if we want to look at the memory address of our variable? Like we have a string x, right, whose value is like Ford, and we want to see on which memory address is it stored in, right? So we can use the AND operator that will show us the memory address of the variable. So let's just try it out. Should I delete this code?
Yeah.
Alright, so we'll just say cout and x, right? So now this is, we are not creating any references over here. This will show us the memory address of x. You remember when we were creating arrays, like over here we'll just create a string array.
Yeah, when you print it, the memory
Yeah,
address comes up when you give it
yeah.
in the square
So
brackets.
whenever printing the array, it by default shows you the memory address, right? But whenever printing the values of string, integer, boolean and all, it shows you the value. So to get the memory address of those things also, you can use the AND operator, right? And it will give us the
Okay.
memory address of our variable. Note the memory address is in a hexadecimal form, so the number you are getting is in hexadecimal. So note that you may not get the same result in your program. So like over here in this W3 schools, the variable is being saved in some memory address. Over here in our case, it's being stored in some memory address in your computer, right? So if you also try it out,
Oh,
it will be different from what we are getting over here, right?
yeah.
And why is it useful to know the memory address? References and pointers, which you will learn in the next chapter, are important in C++ because they give you the ability to manipulate the data in the computer's memory. Right, so you can directly work with the computer's memory, which can reduce the code and improve the performance. Right, these two features are the one of the things that make C++ stand out from other programming languages like Python and Java. So this was it for this class, and we'll look at pointers tomorrow in the next class, and I hope you like the class.
Okay. Yeah, it was nice. Thank you.
Thank you.